Talking, which means that we're going to get started. We are talking about triangle proofs today, specifically looking at SSS and SAS, side, angle, side. What information about two triangles allows you to conclude the triangles are congruent? We're going to apply side, and side, angle, side, to construct triangles and to solve problems. We're going to prove triangles are congruent. Today we'll be looking at side, and angle, side. Key vocab, triangle rigidity, included angle and included side. Rigidity. All right, let's break this down. Property of triangle rigidity gives you a shortcut for proving two triangles are congruent. This property says that if the side lengths of a triangle are given, the triangle can only have one shape. So think about it. If I give you the sides 10, 15, and 20, that's the only shape you can make with a triangle, correct? 10, one side's 10, one side's 15, one side's 20. That's what triangle rigidity means. It's a rigid triangle. It does not change. It is different than a variable, for example, in an algebra problem. Okay, how does this work in problems? Well, first off, we have what we call the side, congruence postulate. I'm going to write this down. Side, congruence postulate. Okay? It says if three sides of one triangle are congruent to, the three sides of another triangle, then the triangles are congruent. How do we prove triangle congruence? One way is through side. If three sides of one triangle are congruent to three sides of another triangle, those two triangles are congruent. So in this example, A to B is congruent to FD. B to C is congruent B to E, and C to A is congruent E to F. We call that side. Good.
Yes, sir.
How many angles am I using in the side congruence postulate?
That'd be 0.
That will be 0. How many sides do I have to have?
3. Side.
If I got one side, is that enough?
No, sir.
Two sides?
No, sir.
You get your full course right here, right?
Oh.
3 sides.
3 or none.
3 or none. You got me?
Game first, you last.
It's like the best little restaurant you can go to, right? Most of the restaurants, you get how many sides?
Just 2.
Just 2.
Unless sometimes you get meat in 3 places, but it's a little more expensive.
Coach, this one, we get our meat and 3 for the same price that we get our meat and 2. All right? Meat and 3 sides. All 3 sides that you got to have. Okay? All right, how does this work? Go back. We need to. First, we got to talk about this. You should know what this is, but let's make sure we got it down. An included angle is an angle formed by 2 adjacent sides of a polygon. Angle B is included between sides AB and BC. We got it. When AB hooks up with CB, they meet and form angle B. We call B the included angle between AB and BC. Thank you for erasing that, because I know for a fact nobody's going to write on my desk for this they do, they will be having attention. After school. Oh, no, you don't sit down in this position. Oh, no. Jumping jack. Dang right. Go ahead. Get the best 6-minute workout of your life.
Let's do it, because I need to get back in shape.
Wall squats,
Right on your desk. See what happens.
bows and toes.
Do it.
Right on. Right. Aren't you a bus driver? You're not. Even better.
Shit, I'm on it. Well, I gotta go make up some other class.
I don't care. You can do that on your own.
Well, I had you coming up in the gym.
Oh, yeah.
I go out of there regularly. That's why it's so good. Not nothing. You got to
We need to know what an included angle is because we're going to use it in our side congruence postulate, side angle side. It says if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, my triangles are congruent. First one we looked at was side, side, side. This one is side, angle, side. Coach, instead of 3 sides, how many sides did we get on this?
2 sides.
2 sides. And we're substituting. Coach, you like to do that? You go to a restaurant, they say, hey, get 2 sides. And they say, you get 2 sides, no substituting. You got to pick from this list. You hate that, don't you?
I hate that.
I hate that too, man. It's like, guys, what if I don't like your food? What's your mashed potato stuff? What if I'm not in the mood for green beans and hash casserole? What if I really want something else? Well, here, instead of getting 3 sides, here's what we can do now. We can substitute an included angle for one of the sides. So here's how this should be working right now. You sit there being like, all right, I get the side thing. Yes, sir. 3 sides of one triangle can go to 3 sides of another. All right, boss, I got you there. But an angle that's included, yep. Think about this. Take away one of the sides, but you include the angle that's between the 2 congruent sides, you're good. Coach, what if I try to use a non-included angle with 2 sides?
Ain't gonna happen. Ain't gonna work.
It ain't gonna work, Coach. What's it gonna give me?
It's gonna give you side angle,
Or the other way around, which is
angle side.
Coach secondary word there.
I tried not to.
Angle side.
You tricked me into that one.
I got you
You
there.
got me anyway. Trickeration.
So bad kids. They end up in like you, Bradley. I mean, Bradley, you're a good kid, right?
I get it. Now tonight,
You're not an angle side.
I only had eyes for all of high school and
This year. That's the
same
angle.
old eyes. I don't get nothing for it.
Don't even stand.
I only have one stop.
Don't even
You got one
stand.
time every year.
All right. Let's move on a little bit. Okay. Check this out, guys. This is kind of the work we're going to be doing today. Use side to explain why triangle ABC is congruent to triangle DBC. Watch how we work this. It's called triangle proof. Okay? This is what they write down here is the thinking you should have. So here's what you should think. First off, what do these tick marks mean? Well, the tick marks mean congruent. It means that a segment with 2 tick marks is congruent to a segment with another 2 tick marks. So in this case, AC is congruent to DC. Hot dog, I got one side of each triangle so far. Then I'm given AB, which is congruent to DD. Well, no longer are we eating hot dogs, now we're up to hamburgers. Okay? I got 2 sides. How many more do I need?
Just
One more side. Cameron, do I have it? Very good. How do I have the BC is congruent to itself? And what do we call that property? The reflexive property tells me that BC is congruent to itself, which helps you out. Come over here to BC. Draw yourself 3 different tick marks. And then I've got 1, 2, 3 sides of one triangle congruent to 3 sides of another. Okay? Austin. If AB is 5, how much is B to D? Austin, if A to C is 4, how much is C to D? BC, let's make it 6, Austin. Do I still have triangle congruence? Say yes. Okay. Yes, you do, okay? I want everybody to understand this. This theorem, this postulate does not mean that all 3 sides have to be the same in one triangle. It means the measures of the lengths of 3 sides of one triangle are equal or the same as the measures of the lengths of 3 sides of another. Okay? Some of you, when I cut you loose here in a couple minutes, you're going to be sitting there saying, well, I ain't equilateral. Equilateral, how do you got to get side, side, side? That's okay. It's okay that they aren't all the same measurements. The side lengths don't have to be the same measurements. It's just that the 3 side lengths of one triangle have to be the same as the 3 side lengths of the other. Okay? Look how side angle side would work here. Prior, BC. BC, is it congruent to itself? To what property? What? When you look in a mirror, what comes back at you? Your reflection.
sing it, Mikey. Oh.
Okay, all right. So now, now I've got A to B congruent to B to B. I've got angle ABC congruent to angle BBC, and I've got side BC congruent to itself. So this tells me side, angle, side in one triangle is congruent to side, angle, side in another triangle. Okay? So are these 2 triangles congruent? Yes, they are. Through what theorem? Side, angle, side. Okay? That's how we work these types of problems. All right? Mooneyham, you're going to get the question. Don't mess this up, son. What if I took away those particular angles and I said, hey man, this angle right here and that angle right there are congruent. Do I still have my side angle side? See what you've done? You've gone and done it, man. What do we call this? Is this a side or an angle right here? What do we call this? Side or an angle? Oh no, you can't cheat like that. C to B, is it called a side or an angle? B to A, is it called a side or an angle? Mooneyham, you're cheating it. B to A, is it? Because when you don't put your angles in between your sides, this shows. All right? All right. It's a very common thing, and I did it to them on purpose instead of on the right? Whenever my angle is not included between my 2 sides, you have angle side to side. If any of you tries to use angle side to side on me, I'll tell you what, that will be harassment. I will tell your mama, your daddy, your auntie, your uncle, your cousins, your priests, pastor, brothers, sisters, and all your little friends what you try to do to me.
Put it on the interweb.
Yeah, Paul, I mean it. You ever heard of Twitter, Facebook, Instagram?
We'll even Snapchat it out there.
I'll even go to Snapchat, so 2012, it's still you. All right.
I just have got it, Coach.
Hey guys, this is what we're trying, this is the goal. So I got a couple of these on the work today because this is what we want to be able to try and do. It's given that QP bisects angle RQS. Okay? An angle bisector takes a big angle and it cuts it into two smaller congruent angles, cuts it in half. It's also given that QR is congruent to QS. Okay? So I go through, I'm trying to prove that these two triangles are congruent. Foster. How do I know that QR is congruent to QS? Perfect. How do I know that QP bisects angle RQS? How do I know that a bisector cuts an angle into two congruent angles? Awesome. How do I know that QP is congruent to itself? Cameron, what theorem would let me conclude that these two triangles are congruent? Go quick. Cameron, R to Q is it side or an angle? Side, angle, side, side, angle, side. Yes. Okay. That's all I got to do. Right. I think we do HL later. Guys, that's all I got today. Okay.